Hi, this is Nicole Hershey, and for my surveillance project, I decided to look at the incidence rate of melanoma of the skin. Specifically, I was interested in regional and gender differences. Go ahead and get started. First, we'll begin with some melanoma background. There are two types of skin cancer. There's melanoma and non-melanoma. Melanoma, which is the focus of this project, is less frequent, but it's also more aggressive. It accounts for 77% of all skin cancer deaths. It originates in the melanocytes, and those are the cells in the skin that produce pigment or melanin. The annual cost of treating melanoma in the U.S. is estimated at $3.3 billion. So you can see the need for understanding the epidemiology behind the disease. Next, we'll start getting into some of the background of melanoma. Of the 7 most common cancers in the U.S., melanoma is the only one whose incidence is actually increasing. So between 2000 and 2009, which is around the framework of what I actually ended up studying, the incidence climbed 1.9% annually. And then another fact about just how common melanoma is and how effective it is on people's lives, one person dies of melanoma every hour, technically every 57 minutes. And then about 86% of melanomas can be attributed to exposure to UV radiation from the sun. And then finally, regular daily use of SPF 15 or higher sunscreen reduces the risk of developing melanoma by 50%. So these first 2 points, you see that melanoma is still on the rise, and it's important to get a better understanding of how the disease is populating to target certain populations for intervention. And then these last 2 points indicate that there are some points of intervention that can be addressed if certain populations are known to be at risk. So a little bit more on background, we're going to review 2 categories of risk factors. The first are these inherent risks, and then the next slide we'll talk about some of the preventable risks. But you can see that melanoma is the most common form of cancer for young adults aged 25 to 29, and it's the most common form of cancer for young people aged 15 to 29 years old. So the younger populations are at higher risk inherently. And then you also have the statistic that an estimated 42,670 new cases of invasive melanoma will be reported in men, while only 31,200 in women in the U.S. in the year 2015. So you see there that men are at a higher risk of developing melanoma than females based off of those statistics. And then finally, the annual incidence rate of melanoma is 1 per 100,000 in African Americans, 4 per 100,000 in Hispanics, and then 25 per 100,000 in non-Hispanic whites. So here you can see just between African Americans and non-Hispanic whites, there's a 25 times difference in the annual incidence rate of melanoma. So non-Hispanic whites are at much greater risk of developing melanoma. And now we'll talk about some of the preventable risk factors that kind of help put some of these entertaining clip arts on here. So first of all, sustaining 5 or more sunburns in youth increases your lifetime melanoma risk by 80%, which is a pretty impressive statistic. And then there's also the fact that more people are developing skin cancer because of tanning than those that develop lung cancer because of smoking. And then finally, just one indoor tanning session increases a user's chance of developing melanoma by 20%. and each additional session after that during the same year boosts the risk almost another 2%, which was a really interesting study that was done pretty recently. So now that we've covered some background, we can get into my specific project. The questions I developed were the following. What are the melanoma incidence rates for non-Hispanic Caucasian males and females in the United States for the years 1999 to 2011? Basically the same question, but based off of geographic region, you see on the second question. And then finally, when considering the melanoma incidence rate for non-Hispanic Caucasians by gender and geographic region, are there any statistically significant differences for the years 1999 to 2011? Note that I specifically am looking at the non-Hispanic Caucasian group, as we went over in the last couple slides. That group of that particular demographic is at higher risk of developing melanoma. And I wanted to avoid race as a confounding factor, so I just looked at that one group. And as I go forward, when I refer to any of the populations or the statistics, just know that I'm talking about for specifically non-Hispanic Caucasians, even if I don't specifically indicate it. I'd also like to point out the significance of these questions. As I was previously discussing, melanoma is a cancer that can be affected by intervention because it has many preventable risk factors. Knowing which populations, geographically and gender-wise, are more at risk will help focus those interventions. So before settling on how I wanted to define these geographic regions that I was going to look at, I took a peek at the distribution of the incidence rates across the United States, which you see here on the left. I originally thought it might be distributed based on state latitude, but I ended up finding that there was a stronger pattern for coastal versus non-coastal states, so I decided to go with that as my geographic determination. I decided to only include coastal states defined by those bordering an ocean or the Gulf of Mexico. On the right here, you'll see those are the states highlighted in red. And I wasn't particularly interested in including those states that are defined as coastal by the fact that they border the lakes, which are the Great Lakes, which are highlighted in the pink on the right. In total, the coastal states highlighted in the red are about 23 states. You can see them all listed on the bottom there if you are interested. The source of my data was the CDC Wonder website, which you can see a screenshot of here. They have a nice, easy-to-use interface that contains pretty impressive data on cancer incidence rates and mortality rates that can be filtered depending on what you are interested in. So it's really perfect for my specific questions. You can see their website up top here, wonder.cdc.gov/cancer.html. And you can also see here that the statistics run from 1999 through 2011. So the collection method that the CDC Wonder website uses is basically the United States Cancer Statistics, or the USCS, which are the official federal statistics on cancer incidence. And they're collected from registries from all 50 states, including the District of Columbia. So when I say US, that's what I'm referring, the 50 states and DC. And they're produced by the CDC and also the National Cancer Institute. So there's a lot of effort that goes into the collection of these data points. And then the incidence data are provided specifically by the Centers for Disease Control and Prevention, specifically the National Program of Cancer Registries, and then the National Cancer Institute Surveillance, Epidemiology, and End Results, or SEER program. For my purposes, the data was filtered by site. So this was melanoma of the skin, state, gender, and this was done for all non-Hispanic Caucasians from 1999 through 2011. There were only a few limitations to the data. First, there are some states that are missing data for the indicated year listed in the first bullet point. There were unfortunately no reasons provided for the missing data, so we just have to take that into account. There is some missing data. And then for the year 2005, there was a displacement of up to over 200,000 or so people due to hurricanes Katrina and Rita, and that was also not taken into account. But overall, I feel that the quality of the data is pretty good, considering the years and the scope of the data. So here you see the overall summary of the analysis that I performed. To orient yourself, notice that there are three main categories of statistics. You have all genders in brown, females in orange, and males in red. Notice that these incidence rates are presented for all regions, or the U.S. as a whole, and then in coastal and non-coastal regions. Also notice that in the first column here that the mean incidence rate for the country overall was 22.78. From there you see an overall trend of incident rates being lower in females and higher in males, with an incident rate that is between when you look at all genders. Finally, you see that males in the coastal regions have the highest mean incident rate at 32.67, and also the most varied incidence rate as indicated by the large standard deviation. This is the same data from the previous figure presented in box plots, and it's only looking at my first question, which was whether or not region had a significant impact on incidence rate. So you can see by way of two-sample t-tests that there was a significantly different incidence rate. Specifically, the coastal incidence rate was significantly higher than the non-coastal, and that was with a p-value of 0.002. Now we'll move on to my next question about whether or not gender significantly affects the melanoma incidence rate, which we kind of suspected based off of previous research, but we just wanted to show it here as well. Here you have some maps that show a good depiction of the distribution of the incidence rates across the U.S. based on gender. Notice that the scales for the coloration of the map are the same for both females and males. On the left, you see the females with overall lower incidence rate indicated by the widespread yellow. And then the males on the right depict much more dark and red, representing a higher incidence rate. Go ahead and quantify what we looked at in the last slide. Here again, we have the smaller look at an overall data that was presented a few slides back. Females on the left show a lower incidence rate than males on the right, which is significant by the way of two-sample t-test with a p-value of 0.00, which is pretty impressive. Okay, finally, we're going to focus on my last question. Are these combinations of gender and region significantly different? Here I represent these groups as if you were crossing the two factors of gender and region to get females who do and don't live on the coast and males who do and don't live on the coast. You can see a very distinct trend here of increasing incidence that we will discuss further in the next slide. So here I looked at all of the groups of gender and region using ANOVA, and we have this nice summary of the resulting Tukey simultaneous 95% confidence intervals. Basically, as noted at the bottom, if you see a confidence interval crossing over 0, there is not a significant difference in the pairing. So there are two pairings that were not significant. The first being females that live on the coast and don't live on the coast. Those were not significantly different. And then the second one is that males that did not live on the coast, although they have a higher incidence rate than females that don't live on the coast, demonstrated in the previous graph, this difference is not significant. All other pairings were significant, which we'll do an overall summary in the next slide. So in conclusions, in general, people who live in coastal states have a significantly higher melanoma of the skin incidence rate. In general, males have a significantly higher melanoma of the skin incidence rate. And then finally, when combining region and gender, living on a coastal region does not significantly change a female's melanoma of the skin incidence rate, but it does significantly change in males. Of those that live on the coast, males had a significantly higher incidence rate than females. Of those that live in non-coastal areas, males had a significantly higher incident rate than females. Males who live in a non-coastal region do not have a significantly higher incident rate than females who live in a coastal region, which is pretty interesting. And then overall, males who live on the coast have a significantly higher incidence rate than all other geographic gender groups. So I think I accidentally skipped over my limitations slide, and it's not letting me go back now, so I'm just going to discuss it. Sorry that you don't have the actual slide to look at. But in general, a limitation of the study was that I did only look at non-Hispanic whites, although they are the most affected population. I think that this is a good start, but due to the scope of the project, I decided to just stick with one specific. Otherwise, I would have had to do the same analysis over again for each different, basically demographic cohort of people. So future, we could go ahead and do a stratified analysis, including all different demographics of race and gender. And then another limitation, which is something that I think would be interesting to look into, is the fact that the data had no kind of information on, even though most skin melanoma of the skin is caused by UV exposure, it'd be interesting to know, and it wasn't provided, whether or not the person had a high UV exposure history, and definitely look at natural versus artificial UV, so sun versus tanning bed. So in this next step slide, we'll wrap things up pretty quickly here. From the data that we looked at, which was all historical, we found that non-Hispanic Caucasian males who live in coastal regions are actually the most at-risk population for melanoma of the skin. And then just in general, non-Hispanic Caucasians who live in coastal regions, whether you're a male or female, are historically more at risk for melanoma of the skin. So we could allocate additional public health resources towards preventative education for these populations. And then also regional and gender analysis for other race ethnicities, as I was discussing, should be performed. And then, again, analysis considering the cause of melanoma should also be performed. So finally, we reach my references page. If you'd like to browse through any of those, there's some very interesting studies and sites referenced there. And I'd just like to thank you for tuning into my presentation, and I welcome any questions and discussion items that you might have.